All right, if you had trouble with number 19, I think I know why. Can anybody tell me the thing that I noticed right off the bat?
Hours and seconds.
Yeah, the units. So if you look right here, this is in miles, and this is in hours, and this is in seconds. So we have hour over here and second over here. Are those going to work together? Typically in physics, we don't want to be in miles. Typically in physics, we want to be in meters. So let's take this 175 mile per hour right here, and we're going to convert this to meters per second. So 175 miles per hour. So we're going to cancel the miles. We'll put that in the miles in the bottom, meters in the top. What's the conversion? Who runs track? What do they call the mile? 1600. 1 mile is 1,000. It's actually 1,609. And then we're going to cancel the hours. Put hour up top, seconds on the bottom. 1 hour is 3,600 seconds. So 175 miles per hour is 78.215. 78.215 meter per second. So see here, the miles cancel, the hours cancel, and you're left with meter per second. Okay, so this airplane is going off the side of an aircraft carrier. So here's I'm a really bad artist. So here it is, V final. Over here is 78.215 meter per second. Sig figs are not going to be a big deal in this class. Just don't round until the end. You know, if you go out to the thousands place out here, that's fine. Just take it to the thousands place. When you do get to the end of your calculation, just round it to the tenths place. All right, so what other information do we have? We're given the time it takes for this acceleration to occur as 2.5 seconds. We don't know the acceleration, and we don't know the total displacement. So X is a question mark. Okay, so first thing we're finding is the average acceleration of the plane. So the motion equation that's going to do it, I would use, let's see, with the information we have, we're going to go VF equals V initial plus AT. Is that going to work? Yeah. Yep. So what's V initial? 0, so we can cross that out. Don't plug the numbers in yet. Plug the numbers in after you've done the algebra. So we're solving for A. A will be V final over T. And now plug the numbers in. 78.215 divided by 2.5 seconds gives an acceleration of 31.3. So now we can round this. Unless, of course, you're going to use the acceleration in another calculation. If you're going to use this value right here, the 31.3, if you're going to plug that into another equation, then use the unrounded. Okay? Okay, B, the distance the plane moves. Here, distance is the same as displacement. Why is distance and displacement the same? Because there's no change in direction. The only time distance and displacement are different is if there's a change of direction. So we're solving for X now. So I think the easiest one to use is the first kinematic. X equals 1/2 AT squared plus V initial T. The initial velocity is 0. It starts at rest. So now we can just plug in. The acceleration, oh, hey, we're using it. So 31 point, it was actually 286. Use the unrounded value. And then the time is 2.5 seconds. Squared, you square that. Okay, so 2.5 squared times 31.286 divided by 2. So rounding this off gives 97.8 meters.